Very good afternoon to one and all present here and the respective members of the jury. My name is Akash Kamlesh, and I'm joined with Anirudh Lakotia and Tanishta Hota. We are students from PS University, and we have come to showcase our Project Bharat. So over to Tanishta.
So I would like to give an overview of today's presentation. We will be talking about Bharat, our contributions, the steps we used and how we implemented it, and lastly, a code walkthrough. India, as you all know, is a land of diverse linguistic and millions speak various languages. Our project, Bharat, aims to break language barriers and promotes inclusivity with the power of technology. So with Bharat, we are giving inputs with both Hindi and English, and this helps in code switching. And we have many downstream tasks, for example, question answering and logical reasoning, to name a few. And here we have asked questions in, it's a mix of Hindi and English, and it's like a basic how you would type a question, right? And the model could give an output in Hindi as that was a desired language. We also asked a logical reasoning question where we asked the model to do math questions, and it gave an output in Kannada.
So this particular example is taken from the very popular GSM 8K dataset, and we have used this dataset to test, to do some inference with our models. So we have a logical reasoning task, and as shown before, we have also a question answering task. More details coming to.
So if you guys are not following yet, our project aims to be a multilingual chat GPT of sorts. So you could talk to it in English, Hindi, or Kannada, or even a mix of all three. And it would give you a response back in your desired language. It could be Hindi, it could be Kannada, or English. Coming to our contributions, we aim to change this NLP space, which today is focused on mostly English. We want to bring attention to Indic languages, which is now the trend in India as well, and we are proud of it. So we have designed robust tokenization tools that could tailor to the intricate structures of the languages itself. Currently, the challenges that are faced by existing models, foundational models like the Llama 2, are that the tokenizer itself is based on mostly English, and it cannot capture the intricacies of Hindi or Kannada. It's not efficient enough to store them. And the majority of our project is to facilitate comprehensive understanding of these languages and generate them using a completely new architecture itself. So I'd like to categorize our contributions as mainly the tokenizer itself. High quality data sets. By this, I mean existing data sets that have been used extensively for tasks like this by IIT Madras, AI for Bharat, for example, or IIT Bombay, and a lot more existing data sets. And we have performed extensive cleaning on these, because what happens with these data sets is that they are scraped from the web, from random books that you find, from legal documents, from a lot of different sources to include that cultural aspect of India itself. But they're not really clean. So if you're talking about split letters in these languages, they're not captured well enough. So we've followed a few research papers, and we've performed cleaning such that we are able to eliminate these kind of inconsistencies in data itself. The majority, the best part about the project itself is the models. So we are going to release a suite of models that can perform the multilingual downstream tasks that we spoke about. And the last contribution is just the utilities itself. So we believe that the majority of learning does not happen in what you're supposed to implement itself. In our case, these models. Along the way, we hit a lot of problems that were not documented, or we wanted to see that how is our data set really distributed? What do we have, like only small sentences, or do we have large sentences? Stuff like that. So we have built a lot of utilities that would help people solve problems like this if they ever run into them. Yeah. So just to talk you through the roadmap, we prepared and set up data sets, we set up tokenizers, and then we pre-trained our models, and then we fine-tuned our models on specific downstream tasks that we'll be talking about in a little while. And then we implemented a new architecture that has not been explored in academia yet. So we have implemented a mixture of experts architecture, and then we implemented something called language routing, which could select which expert to route the tokens to. Then we created a Python package. So we published a Python package with extensive documentation on PyPy, so it becomes very easy to follow, and you could just directly use it out of the box. And we're here for the demo today.
Okay, so coming to step 0, which is the ground step. So as Anirudh spoke about the tokenizers, so coming into a little more depth, we created 2 byte pair encoding sentence piece tokenizers because this is the same architecture Llama 2 follows behind the scenes. So we expanded the vocabulary to approximately 48,000 tokens, and this resulted in a consistent 7.5% reduction in the number of tokens that were required on inference. Now, why is this important? Because there's a lot of problems with the existing Llama 2 tokenizer for other languages, specifically creating a lot of unknown tokens. The merging process, the algorithm is wrong itself. So the extended vocabulary in our tokenizers results in a very in a reduction in the tokens itself and better quality tokenization.
So we used a diverse collection of data sets for incorporating the cultural aspects of the language. We used Hindi Wikipedia articles, which consisted of 172,000 rows. We also augmented rows using Bing AI, incorporating worldly knowledge.
Okay, so coming to the first step for the model, the pre-training step, we spoke about something called continual pre-training, which is what we've leveraged with our model. So we first start with the Llama 2 model, the Llama 2 7 billion flavor, and we add LoRa adapters to the model, and we pre-train this LoRa adapter, the LoRa adapters on on the diverse collection of data sets that Tanishta just mentioned. So we use the LoRa rank of 64 and the fixed alpha value of 16, and we had training batch size of around 8. So fine-tuning was, after we pre-trained our language model, we merged them to 16-bit VLLMs, and we loaded them, and we created 4 instances of the pre-trained models, each for fine-tuning on these 4 downstream tasks. We identified 4 main tasks, first one being machine translation, second one being question answering, third one being logical reasoning, and the last one, as we all know, is general instruct tuning. So for fine-tuning, we followed a very similar protocol to pre-training, which was using the LoRa adapters itself. So we chose a LoRa rank of 32 because the intricacies and the cultural aspect was learned in the pre-training step. So the fine-tuning phase is only to enhance the base model's performance across various tasks, right? So we used a framework called Unsloth. So if you're not aware of this framework, it's a very popular open source framework that leverages fine-tuning with 2.2x memory efficiency during training and during inference. Okay. So the step 4 was to do mixture of experts. We initially contemplated a task-specific mixture of experts. What I mean by that, that was where you had experts. That is, the experts here are the fine-tuned models, right? So we contemplated having fine-tuned models from different languages into one setup, but this posed a lot of challenges, mainly due to the fact that we're not using the same tokenizer for each language model, right? So this would cause a lot of scalability issues. So we pivoted to a language-specific mixture of experts approach. So this is where you had a mixture of experts for a particular language using the fine-tuned model. So you would have an expert for Kannada, an expert for Hindi, and for English. And to do this, we used, this is where something that we found very interesting came in. We used something called MergeKit. MergeKit is another open source platform that enables gradient-free mixture of experts. This is important because training a mixture of experts is very, very, very compute heavy, and using a gradient-free algorithm reduces the memory requirement and the compute requirement exponentially. So we end up with the sparse layers mixture of experts.
Okay, so we spoke about a lot of technical details, and just to give you an overview of everything that we've spoken about, we got input text from existing data sets, a lot of them. We processed them using algorithms mentioned in research papers, doing filtering, correction, and all of that. So at the end of pre-processing, we get the text that we use as source, and we identify the source and the target languages from that. We give it to the language router itself that we spoke about. We implemented a language router. This router would then route the tokens to the specific experts that specialize in the tasks that we mentioned, like question answering or logical reasoning. things like that. And then in the end, we get a response from all of these experts, and that's how the whole project works. Just to talk through a code a little bit, we're running out of time. So essentially, we've split the code such that we have the source code for the package itself, the code for the tokenizers, because we feel that it's important, and there might be things from the open source community that could benefit, that we could benefit from and enhance tokenizers further. And the other folder is about the utilities itself that we spoke about. So we have a collab notebook that we will not be running right now due to the lack of time. But essentially, this is a well-documented collab notebook that you could just run out of the box, and you could try any of our models that we have released right away. This is the documentation. These are a few models that we have released. So there's machine translation, there's question answering, there's our instruct tune model, and there's all of that. We are loading the unsloth adapter to perform faster inferencing also. This is just the general prompt template that we have been using so far. And yeah, you could essentially just start using this notebook out of the box.
So one important point to note here. Time's up. Time's up. Okay. So important point to note here is this is all on a single GPU, running on a single collab GPU on free tier. And just to show you a small demo. So this was the mixture of experts demo that we wanted to talk to you about. So you had your input conversation in Kannada and you wanted your output in Hindi. And you can see that there's an English intermediary that's happening. And we considered Google Translate just to verify the outputs that are coming out as correct or not. So this, so the input, So this was an example for translation. So you can see translate the dog and cat are playing with each other on the sofa, for example, and the target language is Hindi. You can see the response on the right-hand side. So the first example that we showed you was with code switching, where we had an input in Kannada and in Hindi, and you wanted the output in Hindi, right? So that task was achieved. And the second one is performing efficient translation, which was based off the downstream tasks that we fine-tune the models on. So this is a very short demo for our mixture of experts because we're running out of time.
All right, questions?
Any questions?
Hello.
Very interesting proposition. So if I were to look at the core contributions, right, apart from the things that you have leveraged, one of the things that you mentioned is you reduce the vocabulary size for Indian languages by smart tokenization. And you said you referred to some paper where Mozolakshar things like split words, right? Can you tell me one specific new thing that you borrowed from that paper and implemented?
So this split letter thing is something that we, So is it this? So yeah. So one specific thing that we implemented from this paper was from this paper called MADLAT 400 by Alan AI. So they speak about this split letter problem that you have, in which you are not able to represent these tumhare, like the MH kind of split correctly. And so what happens on the web is that you'll see an M and then you'll see a weird circle kind of symbol, and then that splits to an H. So that kind of introduces very unknown tokens, a very random kind of behavior in the model itself. So they have performed something called Virama correction, which corrects this to the correct half letter itself.
So it was like an open source available code, and you just
they have mentioned their code from like how they filter and everything. So we borrowed that from there. That was one specific thing. But in general, there are also problems with other languages. So with Chinese in specific, there are a lot of problems that a lot of papers explore. But we were looking at Hindi and Kannada, which are not really that explored yet.
Okay, and what does it take you to expand this beyond Hindi, Kannada, and English? I mean, other languages, it's more about the pre-training that you mentioned, that's the only effort?
So it depends on the kind of languages we're talking about also. So a lot of times you won't have as extensive data for Hindi or Kannada also. So the languages like Assamese and Bengali, for example, you have some kind of extensive data for Bengali available out there. But for Assamese, there is very, very less data. So what you can do is you can train the model on Bengali in the same steps as we have. So you do this continual pre-training step, where the pre-trained Llama base model, you perform continual pre-training on Bengali itself. So you can teach it about the Bengali tokens and everything. And then you could extend this knowledge of Bengali to Assamese. So you could transfer the learning from Bengali to Assamese. So it depends on the resource, how much
Understood,
resource is
yeah.
available in that kind of thing.
Interesting.
So this is a question from Priyank from Axel. So his question is, how is this similar but different from OpenHathi?
Okay, so OpenHathi is, so they released their base model and they have an Airavata instruct tune model as well. So the thing is, they just have a base model and they just have an instruct tune model on a lot of tasks. So we found that creating experts on different tasks separately has worked out better in the past as well. So the original Mixtral paper did say that, and they specifically mentioned that in the results as well. So we followed along the same pipeline and we decided that having an expert on downstream tasks is better than creating one instruct model on a lot of tasks combined together. So how is it different as such? That is one of the main points that we wanted to make. Yeah, and we have a mixture of experts while theirs is just an instruct tune model.
But the Sarvam team, the OpenHathi team, they claim that their tokenizer is 6 times more efficient than the Llama tokenizer. But you have only a 7% or something improvement. Why didn't you consider their tokenizer instead of building your own tokenizer?
So that's a very good question actually. But the only problem that we found while doing that was we are creating our own pre-trained model and using the tokenizer from somewhere else. We wanted to create everything in-house and we wanted to experiment it in-house itself. So we could have always just taken the tokenizer from OpenHathi, but that would be the same as, if I have the tokenizer, I might as well just take the model as well, right? Why make my own model at the end of the day? So we wanted to create everything in-house and see how it works out first, and further open source collaboration can be encouraged.
One question I think you covered partly in that, like, for how do you select a particular expert for a particular task? Like, what is the selection based on?
Okay, so is it okay if I just take 2 minutes? Okay, so I spoke about something called merge kit, and there's something called language. We've made a language router, as you can see over there. So there's one step here. The language router identifies the language expert that the tokens have to go to. So the language router will tell you which language expert to go to. So you can see language expert 1, 2, 3. So you have 3 mixture of experts, which are Hindi, Kannada, and English. And each of those experts were made using merge kit. So inside each box, you have those 4 fine-tuned experts. That is for question answering, logical reasoning, translation, and stuff. So you first do a language routing, which will identify which expert it has to go to. Then internally, you have merge kit, the merge kit expert that decides, it has its own gating network, which decides which token to go to. So if you want me to go to one more step of detail, we used an algorithm called hidden. So hidden represents the hidden states of the LLM itself. So the way merge kit works is it's a gradient-free way of creating a mixture of experts. The normal way of creating a mixture of experts is to create a separate data set which says this expert you have to route to and this expert you have to route to. We have completely eliminated that process, and this is a gradient-free way of doing everything. So there's no training involved at all. There's no gradient descent. This is a completely gradient-free approach. So coming back, in summary, we have a language router which identifies which language expert to go to, and we have the merge kit MoE that was created, which has a gating network based on the hidden representations of the prompts that you pass it to.
All right. Yeah, maybe you could have said that I'm assuming you trained your own language router also, right? In your case.
Yes.
So just say that. Be explicit. Okay. Say that we created we got the idea of routers from Mistral paper, language router from another paper, but actually we trained our own language router. Then next one again similarly.
Okay.
See what I'm saying, right? That way it's very clear to them exactly what is your contribution. Right now that they might not know that router they'll probably know from Mistral paper, but language router, whichever paper it is, you could have cited that, but said that we created our own because we had our 3 languages, right? Other thing probably you should have mentioned, I think some others did a better job, which is their work also, I think on Twitter, I'm not super active on Twitter, but at least their work also, along with OpenHathi and others, created a little bit of interest amongst people, especially with the release of Gemini and others, to sort of fine-tune their own language models. There are a whole bunch of ones that came up. They were one of the first ones to sort of ride that wave in the initial part of maybe January, February, right? When you originally demoed it. So that's a nice thing to say. Okay? So you should say that we also part of that community of building more. Yeah, and there's a whole bunch of others then came, Telugu Llama, which again one of our friends have developed, and there are a bunch of others also, which all sort of, I think, a little bit of motivation from them, and also I think OpenHathi originally for creating the first models and putting that out. So good job. Nice to see developing interest as well.
So going by that, just one statement, going by that, just to reiterate, this architecture is novel. It hasn't been done before. And going by Kannada, there's so many LLMs, Kannada Llama, there's Tamil Llama, there's Telugu Llama, there's Chinese Llama, but the whole point here is we went a step forward and fine-tuned task-specific experts, and we've implemented them in a mixture of experts setup with different languages and a language router running parallelly, all on a single GPU. So that in itself is a pretty groundbreaking, I feel.
Just to add on before we leave, yeah, this is the last sentence. Essentially, apart from that, we really hope to take this forward and see where a lot of these ideas go, because there are a lot of new models coming out. There's this Mixtral 8x22 coming out. There is Gemma. There is a lot of big things we didn't try. We stuck with Llama 2 this time, but we've open sourced all our data sets and our models itself. So we hope to see a lot from the community itself. Yeah.
Is there any benchmarks on Indian languages at all?
So there was nothing existing till I think last week. So a fellow classmate of ours, Aditya SK, has built something called I think Indic Eval or something like that.
Okay.
So he's trying to propose a benchmarking framework for Indic languages.
Okay.